Hi everyone, today we're going to revisit the example from the factor theorem video, but we're going to use the comparing coefficients method instead of polynomial division during part 2 to work out the other factors. If you haven't checked out the factor theorem video, check the link in the description box below. Don't forget to like and subscribe if you enjoyed the content, and let's get started. So here's the question again from the 2017 FSMQ OCR exam. It's question 6. So you're given that the equation x cubed minus x squared minus 10x plus 6 equals 0 has two non-integer positive roots, so non-integer meaning not whole numbers, and one negative integer root, so integer here meaning whole number. Part 1 says using the factor theorem find the negative root, and then part 2 says hence solve the equation. So since I've covered part 1 in detail in the previous video, I won't be going through in tremendous detail here, but I will give a quick overview. So like we said, to find the roots we have to substitute the factors of 6 into the function. So here's the factors of 6. So now the question asks for a negative root. So this means that we can immediately eliminate all of the positive factors. So once we've done that, we can start substituting the factors for x in the original function. So here's negative 1 as an example, and we're looking for which of the factors brings the value of the function to 0. So you can see that negative 1 doesn't do that, it brings it to 14. So here's the rest of the factors. And the one we have to pay particular attention to is this negative 3. The value of the function when we substitute in negative 3 becomes 0. So because it's 0, we know that negative 3 is a real root of the function, and therefore the factor is x plus 3. So now that we know this, we can move on to the second part of the question, finding the solutions to the function. This is where the comparing coefficients method comes in. In the previous video, we used polynomial division to see what the remaining factor is when we remove a factor of x plus 3 from the original function. So we ended up being able to describe the original function as a product of x plus 3 and x squared minus 4x plus 2. So we can achieve the same result using the comparing coefficients method. To do this method, we say that there must be two factors for the original function. One of them is the one that we already know, so that's x plus 3, and one of them is this other generic function of order 2, ax squared plus bx plus c, which I've shown in blue here. So how can we use this principle to actually find out what the other factor is? In other words, how can we use it to find the values of a, b, and c? So we start off by multiplying out the brackets. If we start with the x term and we multiply it by everything in the blue, then we end up with this expression, and then we take the 3 and we multiply it by everything in the blue, we end up with this expression here. And this is the total expression after we multiply by all the brackets. So once we're here, we can bunch the like terms together. So you can see that we only got the one x cubed term, which we show in purple. We have two x squared terms, so we bunch them together in red. And we have two x terms, which we bunch together in that greeny blue, and one linear term, which is 3c. So now that we have the equation like this, the next step becomes pretty simple. So we say we look at bx squared plus 3ax squared. So we can see when we look at these two terms that we've got a factor of x squared here. So we can take out this factor of x squared. So that gives us b plus 3a all multiplied by x squared. So we're going to do this throughout the whole function. And in fact, the only two terms we can do this with are the x squared term and the x term. So with the x term, you got 3bx plus cx. So we can remove a factor of x here. So this is what the total expression looks like after you've done all that. And this is the format we need to actually work out the values of a, b, and c. So what do? So we start comparing the coefficients. This is where the method actually gets its name from. So if we look on the left hand side, what's in front of the x cubed here on the left hand side? Well, it looks like there's nothing, but in fact there's actually a 1 there, because 1 times x cubed is just going to look like x cubed. So we write the 1 down. And then on the right hand side, we look at what's in front of the x cubed here. So it's a. So we write our a down. So that means our value for a is 1. So we can do the same thing with the x squared term. On the left hand side, we can see that there's a negative 1. And on the right hand side, in front of the x squared, we got this b plus 3a. So we write that down. Well, we already know our value for a, so we substitute that in. And that gives us a total value for b of negative 4. Now to work out c, there's two methods you can do. So if you look on the left hand side, in front of the x, you've got negative 10. And on the right hand side, you've got 3b plus c. So we can work out this way. But you've also got, on the left hand side, you've got that 6. And on the right hand side, you've got the 3c. So you can compare the linear terms too. So we'll do it both ways just to prove that you can use either one to get your value of c. So negative 10 equals 3b plus c. Well, we've got a value for b already, don't we? So we substitute that in. We end up with negative 10 equals negative 12 plus c, and c equaling 2. And of course, if we look at 6 equals 3c, we just divide through by 3, and that gives us c equals 2 as well. So now we've got our values for a, b, and c. We can go back and we can substitute these in to the original function that we described earlier on. So we've got a equals 1, b equals negative 4, c equals 2. So if we substitute them in, we end up with x cubed minus x squared minus 10x plus 6 is a product of x plus 3 and x squared minus 4x plus 2. So this is what we had when we used the original polynomial division method. So you can see that we can use either method and it gives us the same answer. Now we can go ahead and solve the function to find the real roots. We already know that one of the roots for the function is x equals minus 3 because we worked it out in part 1 of the question. To find the other roots, we need to factorize x squared minus 4x plus 2. I've gone through this whole factorization process in much more detail in the factor theorem video, so refer to there if you're not too sure about this. So when we go ahead and factorize x squared minus 4x plus 2 using the quadratic formula, we end up with x equaling 2 plus root 2 or x equaling 2 minus root 2. So these are the three roots for this function, and that answers part 2 of the question. X can equal negative 3, or it can equal 2 plus square root 2, or it can equal 2 minus square root 2. That's a solution. That's a full solution to both the parts in this question. We're using the comparing coefficients method instead of polynomial division. So now you have two methods to solve the question like this. You can use both to cross-check if you're unsure of an answer in an exam, if you have time, of course. But also, if you get really good at the comparing coefficients method, sometimes you can do it by inspection and you don't have to go out and write every line like we did in this question here. So that's going to do it for today, guys. Thanks for watching, and be sure to like the video if you thought it was helpful. Cheers.